Hello everybody, Retro Game Nerd Match again. It's going to be actually a two-part video. First part of this video is just going to be me talking here for a few minutes, and then the second part of the video is going to be actual repair of a Sega Master System. And I kind of wanted to get back into the whole reason why I got on YouTube, and that was to do repair videos to help people that may need help on repairing their gaming consoles. And so I want to make it clear before I get into the second part of this video that I am in no way a professional at this. Had no schooling for this, nothing for electronics. Everything I've learned is self-taught. And so, you know, if you watch my videos and people that, you know, have a strong background in electronics look at it and say, hey, that's not right, this ain't right, that's not right, whatever. I'm open to criticism. I have absolutely no problem with that, because that's the way I learn, that's the way I develop, and is by, you know, criticism. The type of stuff I don't like, and I have one YouTuber in mind that actually came on to a few of my videos and left comments, and I actually had to block him. I've never blocked anybody before, but this guy was just rude. I guess rude would be the word for it. Went on one of my videos, left a comment, "You're an idiot." That was it. Next video, "That's stupid." Next video, "You're stupid." And finally had to block him, and that's eBay is a joke. I don't know why he felt that way, but you know. Then he sent me a message that says, go to KLOV, KLove or something like that, and learn something. I went there. Has some good information, and I did learn some stuff. But you know, there's no reason or no call for that. I mean, plenty of instruction videos out on YouTube that tell you how to repair stuff, show you ways people repair stuff. And so if you don't like what I'm showing, for all means, move on. I'm just here to help people, and you know, that's about it. So what I'm going to do, the second part of the video, is I'm going to take my camera here. We're going to go into my workshop area and show you the Master System. And the reason why I picked the Master System is because, as you guys know from a few of my earlier videos, that I've been getting quite a few of these, and I've been repairing them. And got one last week. Got it in the mail, and I'll tell you, I literally beat my head on the wall trying to figure this one out. I figured out the initial problem why it wouldn't power up, because that was the issue with it. But there was further problems with it, but I did get it to finally work, and when I take you in there, I'll explain to you how I got it to work. And so guys, that's what I'm going to do. We're going to go on a little trip here. If I can get this off my tripod. So this here is the Sega Master System. This is actually my personal one. One I repaired, actually already sent off. Went to eBay, and I sold it on eBay pretty quick, because you know, I enjoy working on these. I enjoy getting them back out to the gaming community, so people can enjoy these and have fun with them again. I'm not looking to make $1 million bucks off of them. You know, I've seen some of these people have repaired, and they, you know, they put the AV jacks in the back of them, which I've done that on a couple of them. But you know, they want 60, 70, 80 bucks for these, and that's just ridiculous. But anyway, that being said, here it is, and I'm gonna kind of give you a rundown on what I did. To open up the Sega Master System, there's only 6 screws at the bottom here. There's 2 there, two there, and two there. Take those 6 screws out. They're just Phillips head screws, and the top here will pop off. Next, you got this what is known as an RF shield. Again, it has one screw back there, another screw back there, and 2, 3 up front, and the shield pops off. And turn my macro, hopefully on my camera here. Yes. And then inside here, you're going to have a screw in the center, a screw on each side here, screw on each side here, and 2 screws there, one on here, one here. Take those out, and the main board should pop out just like this. Then you can take the second part of the system and kind of just set it to the side. But this system here, actually not this one, but another one I worked on, I've noticed working on these 2 different type of boards. You got one that's made in Taiwan, which is this one here, and actually on the bottom of it, you'll see right down there, made in Taiwan. That's what this one is. And then the other board, actually the one I worked on, was made in China. The China board definitely looks more complex than what this board looks. But you know, it's basically the same thing. What I found out with this board was it had no power to it, and did some research, and what I found out is the Sega Master Systems have a huge problem with what is known as a voltage regulator going bad. And voltage regulator on the one made in China actually sits out. This is a heat sink here. It actually sits outside the heat sink, soldered to the board, and the screw goes in here. However, I guess Taiwan, they do it a little bit different, and I doubt I'll be able to show. Well, yeah, I might be able to get in there, but if you look way back in there, kind of sitting. Let me take my soldering gun here. Maybe I can point to it. Sitting way. Nope, still too thick. Pencil? Yeah. Anyway, sitting way back there, where that pencil is the voltage regulator. On top of that is a Phillips screw. You got to actually take that screw out and flip the board back over. Take these 2 screws out and remove that heat sink. Once you remove that heat sink, you will have it opened up, and this is actually what the voltage regulator looks like. This is actually the one I took out. It's no good. It's a 7805 voltage regulator, and that'll be important in a minute, and I'll explain why. But this is the soldering points for the system, for the voltage regulator. It's these 3 right here. You have your input, your ground, and your output. I believe that's how this is set up, if I remember right. I'm going to turn around. No, that is correct. So, when you test these, you should have 9 volts, roughly 9 volts going into this, a ground, and then 5 volts going out of it, because that's what it is. It's a 5 volt voltage regulator, and it does just that. It regulates it down to 5 volts. So the way you would test that is you would put your negative lead of your tester of your voltage meter here in the center. You would then take your red one, your positive one, test it here. You should get roughly 5 volts of direct current, or 9 volts of direct current. On the output of it, you should get roughly 5 volts of direct current. However, on this, actually the one I repaired, I wasn't getting nothing going out. And this heatsink got hot really fast, which then made me to believe the next thing was a short. And that's where I was pounding my head on the wall, because using my ohm meter here, or my voltmeter here, I turned it over to that, which is continuity or shorts, looking for a short, and when you find it, it'll actually make a beeping sound like that, saying, you know, there's a short. And I'm going to try to do this one-handed, but when I tested between the center one here and this one here, I had a dead short. And I'm telling you, I followed the traces. I looked to see, you know, is it resoldered somewhere? Did solder spill over somewhere? I couldn't find absolutely anything. So what I started doing is pulling things out that combine these two circuits together, excuse me. And on the other board it looks different, but what I ended up finding, and it's actually under the heatsink here, is the C20 capacitor. This ain't it, but I ended up throwing it away. It had continuity between the negative leg and the positive leg, which means it was shorted out. And a capacitor, without trying to get too much, trying to explain too much about a capacitor, there should not be that way. It in a lot of ways it works like a battery. You have your positive and your negative leads, and if you would touch your positive and your negative lead, it would create a short, obviously. Well, on a capacitor, you have a stripe down the side here, and that means that's the negative post, and this side is the positive post. But anyway, so it had a shorted capacitor in it, and the capacitor was a 10 volt 1000 microfarad capacitor. Didn't have a 10 volt 1000 microfarad capacitor. So what I ended up putting in it was a 16 volt 1000 microfarad capacitor, which will work just fine. Which means, what that means is this capacitor will hold a charge up to 10 volts, and then it tops off. The other capacitor will hold a charge all the way up to 16 volts. And don't quote me on it, but from what I've told, and from what I've learned from experience, is that you can use a higher voltage capacitor on a system or on anything, but you can't change the microfarad. So I couldn't put, you know, 100 microfarad capacitor in here. I'd have to use 1000 microfarad, and anything above that 10 volts would be okay. Now, if I'm incorrect, please let me know. But that's the way I've read, and also a buddy of mine explained to me too. So, that being said, I traced these, and I traced them, and I traced them, and I found that capacitor was bad, causing that to short out. So I went ahead and replaced the capacitor, like I said, and I replaced the voltage regulator. Voltage regulator just picked up at Radio Shack, 7805 5 volt voltage regulator. Part number there is 276-1770, and desoldered it from the board, resoldered it to the board, the new one to the board anyway, and ended up changing that capacitor. Actually, the capacitor's under there, but changed the capacitor out, fired up, works great, and turned around and resold it. Didn't make a killing off of it, but it was definitely worth my time. So guys, if you have any questions or comments, let me know. That was kind of my repair here of the Master System. And if I can help anybody any further, please let me know. And everybody have a great day.